Yes, student, again now the most important content of the chapter is what? The chemical properties of phenol. Okay. So again, to check the chemical property, we have to search the electronic structure of phenol. Getting? Structure of phenol. Okay. What is the structure of phenol? In phenol, there is a benzene ring. This is benzene ring and one of the oxygen, and there is one what? Hydrogen. Okay. Now student, there are two lone pair in the oxygen. The oxygen is more electronegative as compared to hydrogen. Therefore, the bond pair is slightly shifted towards oxygen. Thus, oxygen acquires fraction negative charge and the hydrogen acquires fraction positive charge. Okay. So due to polar nature of OH bond and also presence of electron withdrawing group, that is what? Benzene. Okay. Release of hydrogen cation is quite easy. Hence benzene is acidic in nature. So we have to check now some acidic reactions given by the benzene. So the first reaction will become what? When benzene is reacted with active metals. Active metals means highly reactive metals. Like alkali metals, you can write sodium, potassium. Okay, it forms phenate. Okay, that is sodium phenoxide. Okay, sodium phenoxide. This is called simply phenate. Sodium phenoxide and releases H2 gas. Okay, we can write reaction OH plus 2Na. It forms, I am writing in this way, ONA plus H2. To balance it, we can write here 2, we can write here 2. So it easily releases what? Hydrogen gas. Second one is phenol. Now, being it is acidic in nature, so it can neutralize what? Alkali. Phenol neutralizes alkalis. The same reaction will be there. Okay, little bit change, but almost same reaction. You can write here what? OH, and when we react it with what? NaOH, isn't it? NaOH, then it will become what? It will become again phenate ion. ONA plus H2 gas. H2 and what? Water. So the neutralization means what? Here it acts as acid. This become what? Base, and this become salt, and this one is water. Okay, salt and water, isn't it? So this is simply neutralization reaction. Student, The acidic nature of phenol is already again discussed in the previous period, that is when we discussed the acidic nature and the comparison of alcohol and phenol. In that time we have already checked it. How it is? Phenol is acidic and its Ka, that is dissociation constant of its value, Ka value is what? 10 to power minus 10, and pKa value, it is what? 10. Okay, we know that as pKa value is lesser, more will be acidic nature. So the pKa value of alcohols are high and therefore alcohol are less acidic, while the pKa value of phenol is 10, that is less than alcohol, therefore it is even more acidic as compared to water, okay, and also as compared to the alcohol, isn't it? Now we have already again checked why do phenol is more acidic. So this is what? OH. Okay, in solution, aqueous solution, it converts into O anion completely, plus what? It forms H cation. So this ion is known as phenoxide ion. Okay, and now student, you also know that phenoxide ion, okay, stabilize itself by resonance. Now what will happen? If after releasing H cation, phenoxide ion will stabilize itself, okay, then it will not require to again, okay, rebond with hydrogen cation which it is released. That means in the aqueous solution, the hydrogen cation will remains in the free form and therefore it will become what? Acidic in nature. So we have again checked all the resonating structures given by the phenoxide ions, that is the 5 structure, and through the 5 structure it stabilizes itself, therefore the reduced H cations remains in the solution. So by resonance, hence phenols are more acidic, okay, than alcohol. Now can alcohol also shows resonance? So this is not possible, because there are what? Are alkyl radical in the alcohol, and due to presence of alkyl radical, it does not shows what? Resonance. But the phenol, this shows resonance. This is due to delocalization of pi electron pair. If you have to find its comprehensive form or described form, you can check the comparative acidic strength of phenol with alcohol. Yes, student, the next one is the effect of substituents on acidic nature of phenol. Student, there should be 2 types of substituent present with the phenol. So what will be the effect on acidic nature of that compound? That is whether those compound will be more acidic or will be lesser acidic. Okay, let me explain it. Suppose we are having two type of compounds. Say this one is phenol, okay, and another compound there will be phenol, but along with phenol some substituents are present like N, this is O and this is O2, NO2, 1. Okay, let me draw one more compound. This is O and H, and now N double bond O and O2, and one more compound. This is O and H, and now N double bond O and O. So three compounds are there of phenol, 1, 2, 3. This compound is called ortho nitro phenol. This one is meta nitro phenol. Okay, and this one is para nitro phenol. Okay, this is on the basis of attachment of electron withdrawing group. Why these group behaves as electron withdrawing. Electron withdrawing means they are able to withdraw electron. Very first the electrons are withdraws from oxygen to benzene ring, and now the benzene ring becomes what? Electron efficient. So now the oxygen, that is the nitro group, is able to withdraw electron. Means what? Actually what happens? Electron withdrawing group first withdraws electron, thus benzene ring becomes electron deficient, and therefore due to electron deficiency now it withdraws electron from oxygen. Now if the oxygen will become electron deficient, then it will withdraw electron from hydrogen, and thus they can easily release what? Hydrogen. Means what? In case of any electron withdrawing group attach to any position of benzene, any position of benzene ring, then due to electron withdrawing nature, okay. Now electron withdrawing nature means, student, you know that oxygen is more electronegative, nitrogen is less electronegative, means the oxygen can withdraw electron from nitrogen, so the nitrogen will become electron deficient. So now the nitrogen will withdraw electron from benzene ring. Therefore this is called electron withdrawing nature. So in case of any electron withdrawing group attached to any position, remember any position like ortho, meta, para position of benzene ring, then due to electron withdrawing nature, okay, it will create electron density, electron deficiency means there will be deficiency of electron on benzene ring. So now benzene ring, that is nucleus, will withdraw electron from what? Oxygen, and Now oxygen will become electron deficient, will become electron deficient, so oxygen will withdraw electron of which bond? OH bond. OH bond. Okay, so release of H cation, that is, it will release now H cation to become electron efficient. So release of H cation, that is OH bond will release H cation, thus will become what? More acidic. More acidic. That means what? That means all these compounds are more acidic as compared to the phenol. That is, the phenol is least acidic while all these compounds are most acidic. But the most important thing is that out of these three, which one is most acidic? Okay, so now to check this, we have to search the experimental value of pKa. Very first, let me check experimental value of pKa. Student, pKa value decides what? Acidic nature. As lesser pKa value, more will be acidic nature. The pKa value of phenol is 10. The pKa value of this orthonitrophenol, this is what? 7.2. The pKa value of metanitrophenol, this is what? 8.3. And the pKa value of paranitrophenol, this is what? 7.1. So you can check here the least value for what? Paranitrophenol. Okay. On the basis of experimental pKa value. What? First one 7.1 will be most acidic, then 7.2, then 8.3, and the least one is what? 10. Isn't it? Means what? Means paranitrophenol will be most acidic, and simply phenol will be least acidic, and between these two compounds are there. That is what? Meta, and this compound is what? Ortho. So orthonitrophenol. Now the question is that, as there is a concept, if electron withdrawing group is attached with nitro position, okay, then it should be most acidic. But the pKa value suggests the nitrophenol is lesser acidic as compared to paranitrophenol. Now why? This is because in paranitrophenol the charge dispersion is high. Charge dispersion means negative and positive charge having atoms are quite far away apart from each other, and therefore they shows more stability. So due to charge dispersion in paranitrophenol, it becomes most acidic. Now between nitro, that is orthonitro, and metanitro, okay, here the ortho effect becomes more influence, and therefore orthonitrophenol is more acidic. Getting? So between para and ortho derivatives, okay, paranitrophenol is more acidic. Paranitrophenol is more acidic due to high charge dispersal. High charge dispersal. Okay. Therefore, what? Para-nitrophenol is most acidic, then ortho-nitrophenol, then meta-nitrophenol, and then phenol. And now the effect of electron releasing group, ERG. If it is attached with phenol, then how the acidic strength will change or gets effect. Like, let me draw. This is phenol. Okay. Now I am drawing some compound having a group. Okay, which is what? Having electron releasing nature. Now student, you should know that if the alkyl radicals are attached, okay, in the benzene ring, then they shows electron releasing nature. Look at here, the direction of arrow. Now from CH3 to benzene ring. Okay, and the next compound we can check where the position of CH3 is in different carbon. Say suppose if it is attached in meta position, and one more here O and H. Now the CH3 is attached in para position. Okay, so in meta position, in para position, in ortho position. Now what? Let's check its pKa value. pKa value of phenol. What is the pKa value of phenol? You know that this is what? 10. Now, in previous period we have checked it. What is the pKa value of ortho? This is 10.28 pKa. That is higher as compared to phenol. That means it will be more acidic in nature. In case of meta, this is 10.08. Difference, but very less difference, and this is what? 10.14. That means what? That means we can say the phenol is become least acidic. So here you can say phenol is least acidic. Then the more acidic will be out of 1, 2, 3. So which one has higher pKa value? That is more than what? Phenol. Okay, its value is lesser. 10, exactly what? 10. But now in case of meta, its value is 10.08. Means now meta nitrophenol. Meta nitrophenol. I mean, let me check it. Its value is lesser, means phenol will be more acidic, and then little lesser will be meta nitrophenol, then little higher value of para nitrophenol. So para nitrophenol, and the least acidic will be what? Ortho nitrophenol. This is ortho nitrophenol. Now what is the reason behind it? Why do ortho nitrophenol is what? Least acidic. So student, actually again we have to check between any of the two compound what will be the effect. So let me write the reason. In case of electron releasing group attach to benzene ring, okay, it will now this one electron releasing group, it will release electron on benzene ring. Now look at, if electron releasing group will release electron on benzene ring, then the benzene ring will become electron efficient. So benzene, okay, nucleus, you can call it what? Nucleus also. Nucleus will become electron efficient. Will become electron efficient. Okay, so it will release electron on oxygen atom. That means now the electron will be released to oxygen atom. So now oxygen will become electron efficient. Remember, just opposite. Earlier in previous case it was become electron deficient, but now it becomes electron efficient. So oxygen will not easily tend to attract OH bond pair. Means what? When it will becomes electron efficient, now the bond pair will not be attracted by oxygen, and if the bond pair will not be attracted by oxygen, then the H will remains connected with the oxygen. Okay, that means the hydrogen releasing capacity will decrease. Okay, means as greater the tendency of attraction between O and H, okay, the releasing of hydrogen becomes difficult. The release of hydrogen depends on its electron density. If it is less dense, then will attract electron. If it is more dense, then it will not attract electron. So now actually what? Oxygen becomes electron efficient. So now if it in itself becomes electron efficient, then it will not attract electron of OH bond, and thus hydrogen will remain attached with it. Easily tend to attract OH bond electron pair. So hydrogen cation releasing capacity will decrease. So acidic nature decreases. Means what? All the derivatives will be lesser acidic as compared to phenol. That is, in the case of electron releasing group, the phenol will be most acidic. Now student, you can check here. I added 1, 2, 3 same type of methyl radical in all these 3 compounds, but their position are different. Okay, now if the position are different, then there should be some regular trend, but what we are observing, the trend is not regular. Here the metanitrophenol, out of all these 3, metanitrophenol becomes most acidic. That is, if we compare only 1, 2 and 3, the meta position is most acidic. This is because actually what beta, the phenol shows ortho and para effect, it does not shows meta effect. So if the electron releasing group is attached in the meta position, then it will not affect its nature, therefore it is most acidic in nature. And now if we compare between ortho and para, so between ortho and para, you can check here, the para nitrophenol is more acidic. This is as compared to ortho. This is because in para position, the electron releasing group is very, very far away apart from O. So as more distance from O, okay, the releasing nature, that is electron releasing nature, will decrease. So if we compare between these two, the electron releasing nature having group is very near to functional group, therefore its effect is lesser, while here it is what, very, very far, therefore its effect is higher. and therefore between para and ortho, para is more acidic. Is this clear, student? It requires what? Repetition of 2 to 3 times. You have to watch the video 2 to 3 times. Okay. So remember, now we have checked the acidic strength of phenol, comparison with alcohol, comparison with water, comparison in case of electron releasing group, comparison in case of electron withdrawing group. You have to more focus on these phenomenon. Okay, and also you have to focus on pKa values.